In this video, we will discuss a statistical concept called hypothesis testing. What is hypothesis testing? It's a statistical inference method for evaluating the plausibility of a hypothesis based on observed data. A hypothesis is a provisional explanation for a phenomenon. Observed data are realizations of random variables. Suppose we have a random variable that follows a distribution defined by parameter theta. Realizations from this random variable are collectively called observations. We can never know the true value of theta for sure, but we can formulate hypotheses about theta and use the observations to test them. Suppose we have a null hypothesis that says theta has the value theta naught. We can ask the question of how likely are these observations to occur under the null hypothesis. If we conclude that the observations are inconsistent with the predictions of the null hypothesis, then we may want to reject the null hypothesis and accept an alternative hypothesis that says theta takes on the value of theta A. The null hypothesis is a falsifiable hypothesis that can be rejected if the observed data provide sufficient evidence of inconsistency with the hypothesis. The alternative hypothesis is a different hypothesis that can be accepted if the null hypothesis is rejected. Please note that the null hypothesis and the alternative hypothesis are mutually exclusive and contradictory to each other. There are 4 possible outcomes from hypothesis testing. Under the scenario of the null hypothesis being true, if we accept the null hypothesis, then the outcome is a true negative. If we reject the null hypothesis and accept the alternative hypothesis, then the outcome is considered a false positive. Under the scenario of the alternative hypothesis being true, if we reject the null hypothesis and accept the alternative hypothesis, then the outcome is a true positive. If we do not reject the null hypothesis and accept it instead, then the outcome is considered a false negative. The decision criteria used in hypothesis testing are related to the false positive rates and false negative rates. Under the scenario that the null hypothesis is true, we can minimize the probability of rejecting the null hypothesis by requiring a certain statistical significance level. This effectively controls for the false positive rate. Under the scenario that the alternative hypothesis is true, we can reduce the probability of failing to reject the null hypothesis by requiring a certain level of statistical power. This effectively reduces the false negative rate. Please review our other videos for detailed discussions about statistical significance and statistical power. Thank you for watching. See you next time.